What's up, Calc gang? Welcome back to some dynamics. So let's solve this problem. So basically, we have this guy with a jetpack, and he has this thrust pushing him upward. And that thrust is equal to this equation, 500t to the 3/2. And we know that his mass is 100 kilograms. So our goal is to find the speed of the dude at 3 seconds. So he's gonna go, and then at 3 seconds, what's his speed gonna be? And to do that, we're gonna be using the momentum equation, right? Momentum initial plus the sum of the changes in force over time is equal to the final momentum, this equation here. So we recognize, right, we know mass initial, velocity initial is gonna be 0, because velocity initial is 0. And velocity 2, this is what we're solving for. And we're given mass, but what's happening? We need to figure out these forces that are acting on it. So let's figure out the forces really quick, just say them out. So the thrust is pushing them up, and gravity is pushing them down. So those are gonna be the two forces acting on the system. And then we need to find out the time that it acts. So you might just say, oh, well, let's integrate from 0 to 3, because we're going from 0 seconds to 3 seconds. But what we're gonna find out is, this equation is not gonna be enough to pick him off the ground for a certain amount of time. We don't know how much time. He might not even leave the ground within this much time. We need to figure out basically when he's gonna leave the ground, and that's what we need to integrate over. So our first step is gonna find when is he actually gonna leave the ground. And to do that, let's draw a force body diagram. So this is really simple, right? The man's weight is pushing him down, and the thrust is pushing him up. So if we want to find the moment that he leaves, we need to find out when this becomes equal to the weight. So we're going to find when thrust is equal to weight. So thrust is 500t to the 3/2, and weight is equal to mass times gravity. So we're solving for time. We're going to get time is equal to mass, gravity over 500, and then this is going to be raised to the 2/3 power. So let's plug it in, right? We have mass is 100, gravity is 9.81, 500, all that to the 2/3. We get that time is equal to 1.57 seconds. Okay, so from 0 to 1.57 seconds, he's still standing on the ground. So we can't count that into our equation here because no work is being done, I guess you would say. So now let's go back to this equation and let's plug things in. So like I said, this is gonna be equal to 0 because its mass is 100, but its initial velocity is 0. So we're gonna have that 0 plus, and let's sound these forces up. So the first force is the thrust, right? So thrust is gonna go from 1.57 seconds to that 3 seconds. The force of the thrust is 500t to the 3/2 dt. And then the weight is pushing down, so we need to subtract that weight, minus 1.57 to 3. And then the weight is just mass times gravity, dt. And that's going to equal to mass velocity 2. And that's what we're solving for. So we need to figure out these integrals first. So let's do that. So this first one, right? Let's see, did I even solve these on here? I didn't really do that. Let's see. So we can first of all, let's just divide by mass. Yeah, so let's maybe we should solve these integrals, huh? I trust you guys to solve these integrals, right? This is really like simple integrals, but it's gonna be 1 over mass, because we're dividing by mass, to 3, 500t to the 3/2 dg, minus the integral 1.57 to 3. Mass is gonna get canceled because we're divided by mass, so it's just gonna become gravity, dt, that's equal to v2. So I'm gonna leave these integrals for you guys because I don't have the time. I try to go quicker in these videos. So mass, right, 100 kilograms. T is just gonna be on these bounds. Gravity is 9.81, and then you're gonna find V2. And V2 is equal to 11.0 meters a second. There you go. That's how you solve this problem, right? Not too tricky, but right, there's a couple things you need to keep account of when you're doing this type of problems. And that account is, you're not changing velocity, so you cannot put it in your time bounds. You need to find that time. So yeah, thanks for watching. Thanks for supporting me. If you have any questions, leave them in the comments. Check out my playlist to learn more about some dynamics. And I'll see you in the next video. Peace.